Now that we have created our mold, we are ready to cast duplicate patterns with our HD material. We start preparing the mold by placing 2 pieces of real glass, not plexiglass, on each side of the mold to ensure even pressure on the 2 halves of the mold and to ensure that no material escapes during the curing process. Then we wrap rubber bands around the mold. The rubber bands we are using require 3 wraps to provide adequate pressure. We are careful to position the rubber bands so that they will not block the light waves from direct contact with the HD pattern. This is also important to see if the pattern is free of voids and air bubbles. We have thoroughly cleaned the glass prior to this application because it is important that the glass is optically clear and free of any residual from a previous mold or smudges that might prevent the light waves from penetrating the mold, as well as allowing better observation of the mold to spot bubbles in the pattern. Next, we fill the mold with HD material. Here we start to fill the mold from the side, and then let gravity work with us to completely fill the mold cavity. Alternatively, we could also simply squirt some material into the sprue, spin it, a process you'll see in a moment, and then finish filling the cavity. It is important to note at this point that ambient room light, and especially sunlight, can start to cure the HD material prematurely. We avoid this by being careful that the light in our work area will not start the material's curing cycle. An irregular surface on a finished model may be an indication that the light in our work area has contaminated the model. Quite often, before spinning, we can squeeze some of the bubbles out by carefully squeezing the glass plates, causing the bubbles to escape through the sprue opening. Upon close inspection, we can see that the highly detailed areas, in this case the prongs, were not completely filled with material. Obviously, we want to make sure that all of the detail has been filled prior to curing. Therefore, we will demonstrate the most popular method of forcing the material into all areas and forcing out entrapped air. Using the bag supplied with the complete HD kit, we drop the mold into the bag with the sprue side up. Then we put the drawstring around our hand and grab the end of the bag, and then spin the bag as shown, using the centripetal motion to force the material into all of the areas of the mold. If done carefully, the centripetal force of the bag will also keep the material from spilling into the bag. Here we are removing the mold from the bag and inspecting the mold to verify that there is no remaining air entrapment. If small bubbles persist, we could place the mold in a pressure pot set at 25 psi for no longer than 15 minutes. This would also serve to force the material into solution and all areas of the mold before curing. It is important to cure the pattern immediately after this step while the bubbles are still held in solution. Alternatively, we could place the mold in a dark location away from ambient light for a few hours, and any remaining microbubbles will rise or go into solution, resulting in a complete fill in the mold prior to curing. Now that our mold is completely filled, it is time to cure the HD model. Here we are arranging our 2 lighting fixtures facing each other. It is important that we use 2 lights to make sure that we are curing the material from both sides simultaneously. Using only one light may cause uneven curing and may cause an irregular surface on the model. We set our timer for 5 minutes, which is how long the material takes to fully cure using these lights. Some molds may vary in how much time is required. At this point, it should be noted that it is impossible to over-cure the material. However, the minimal shrinkage of the model is affected by curing time, and for consistent weights in models and subsequent castings, we use the same time for each individual mold. Also, note that stone sizes and finger sizes will not change with any shrinkage that occurs in the model. This is sharply different than the way injection wax shrinks. It is important to use the recommended lights that match the proper spectrum required to cure the HD material. This is why the HD kit includes 2 such bulbs, which screw into common lighting fixtures as shown here. Using any other light sources may only partially cure the material, causing wet surfaces that may affect burnout as well as handling problems. This light can be harmful to the eyes, so be sure to use full spectrum protective glasses and not stare in the direction of the lights. Since the bulbs generate very little heat, it should be safe to cover the exposed light as shown here for the duration of the curing process. It is also important to note that the HD material will not cure properly unless the mold is made of a compatible clear silicone rubber. HD material is not compatible with urethane rubber. Also, opaque molding materials are incompatible as they will not allow the light source to reach the HD material. As the timer counts down to 0, We turn off the lights and remove the mold. We remove the rubber bands and the pieces of glass, separate the mold halves, and remove our pattern. Here we have a filled mold similar to the one we have just opened. The HD material is dry to the touch, indicating that the model has been fully cured. When you remove the HD pattern, there may be a small amount of flashing that is easy to remove with a wax tool or with a small brush. Here we are removing the remaining flashing with a toothbrush. We could never do this with wax because wax is unable to take this kind of abuse. The difference between this type of flashing and what you would normally see with wax is that when a mold expands when being filled with wax, the wax solidifies in its expanded state. Since HD material stays in liquid state until it is cured with light, even if some expansion does take place in the filling process or the spinning process, the mold will go back to its normal registered state prior to curing. The flashing, therefore, is not an obstacle. On occasion, we may miss a small bubble inside the mold and leave a tiny imperfection on the model that is now cured. Therefore, we need to repair the model. We can do this by using a small amount of injection wax to touch up and fill in the small imperfections. The HD material itself can also be used for touch-up, as well as bonding patterns together for assembly or sizing. Simply repair or assemble the parts and then cure with light. Finally, we're ready to build our tree, the last step before the burnout process. Generally speaking, it is important to use wax as your sprue material. Here we clip the HD sprue and attach the wax using sticky wax. The reason we clip the sprue is that the wax will evaporate quicker than the HD material, allowing the most amount of heat and air to reach the HD model during the burnout cycle. A heavy gauge sprue material is recommended for the base of the tree. The HD material does not burn quickly, so building our trees in this way again allows for the greatest amount of heat and air to reach the HD model during the burnout process. The one common important consideration for any of the investments used that are gypsum bonded for gold and silver is to achieve the maximum green strength of the material prior to starting the burnout cycle. Check with the manufacturer of the investment material to know exactly when that level is achieved. Casting results are inconsistent in standard phosphate bonded investments for platinum. However, most dental investments for platinum yield excellent castings. From the creation of clear rubber molds using the new HD silicone rubber to the creation of multiple HD models, we have just scratched the surface of the potential of HD. Its combination of accuracy, flow, consistency, flexibility, durability, and compatibility allow the modern artisan and jewelry manufacturer to leverage the latest in design and pattern making technologies in ways previously impossible. HD is truly one of the most significant advancements in the 6,000-year-old art of lost wax casting.